you can add all four, or you can add just the new ones, which would be this, arc length and the radius. But you did this, as I said, in year 8. So what this is saying is we know the circumference of a whole circle is 2 pi r, agreed? Now, if you had, let's have for an example, we had this little sector of the circle and you wanted to find, or you were asked to find that part, that part of the circumference. And they told you that this was 70 degrees, yes? You would find the whole circumference, so you would say 2 times pi, and let's take our radius as 10, times 10, but then what fraction of a circle have you got? 70 degrees out of? Oh my God, Lord, they're saying 46. 360 degrees. I swear you said 46. And you'd happily pump that into your calculator. You wouldn't even bother cancelling, whatever. So that's what this is saying here, right? So this is what we used in year 8, possibly year 7 now. But how are they getting this formula? Well, they're now saying that the circumference, instead of, oh, that's not very nice. Go white. You don't have to write all this stuff down if you don't want to. It's mainly these formulas. I'm just proving that it's nothing new. So circumference, we're now calling the arc length, L. We did the same thing here. So we did the 2 pi times the radius times theta over 360. But what are we saying 360 degrees is in radians now? Oh, they're silent. Oops. Come with you, man. 2 pi is 360 degrees. So this I could replace, that's right. Shh, chatter's up the back. This I could replace with the 2 pi, and so I've got a 2 pi here, they're all times, so that cancels with that, and that's how I get the radius times theta, which is how they get this formula. So we have used it before, correct? We're just fancying it up because now our theta will be in radians. Correct. It will be in radians. So all you really need to do, I mean, you can put all 4 formulas if you want to, but I'd be sort of focusing on this one and exactly how we did this. If that's 2 pi, you can cancel the pi. The 2 stays there. That's why you've got the half. So I'm just proving that these are pretty much the same. Nothing new. I'm assuming the chatter is because this is vaguely insulting to you, and I appreciate that, but let's just go ahead and do it. So we read, find the arc length, because believe it or not, in past years where we think, oh my God, this is just a gimme question in a test or something, people get it wrong. So it's best to make sure you can do. Don't just go out there and think you can do a great tennis serve and then, whoops, no you can't. We practice. So arc length, you write your formula, length equals r times theta. We go, good Lord, that's my radius, 6.2, times pi, or sorry, your theta, which is 2 pi on 3. And the only thing that you have to make sure is that when you are putting this in your calculator, because we see the pi, I saw the pi, we have to make sure that we are now not in degrees, Sean. So we're going to go shift, boom, boom, down to the angle, whack in radians, exit, and now we happily type in what we see. 2 times pi over 3. And we get 4/3 pi. And I'm going to say meters. If the question said, put it to 2 degrees or 3 degrees or significant figures. Oh, 6.2. That's what you're telling me. Sorry. 6.2. Gotcha. Nancy? Did I put 6.2 and it didn't come up? Or who knows? Anyway. Ooh, 62 over 15 pi. Wowza. $62 over 15. You can leave it like that, or as we said, you can put it as a decimal. I probably like to do 2. So 12.99. Simple? Yep, the little C there, that is also code for radians. So if you see that, then you make sure you pop your calculator in radians. Going back and forth, it's just something that you do. All good? Well, I think, shall I leave you to it? You don't have to listen to me because you are clearly very good. Find the area of each sector. Again, I'd be saying just do part C. C. C, senor. And let's work our way through doing the C's and every other question. Okay, go. Let's, as good mathematicians. So your choices for the next minute is silence and doing your own thing, or listening but silence, unless you're answering a question. So find in radians the angle of a sector. Okay, so I'm wanting the angle. It's got a radius of 4.3 and I've got an arc length of 2.95. Now, as soon as I see radius and arc length, I know there's a formula where we have the arc length. Yes, that's how I do my L, everybody. Radius times theta. So it's a simple whack out information in there. So 2.95 equals 4. Who was talking? That wasn't silent. 4.3 times theta. Therefore, theta is 2.95 over 4.3, and you'll get your answer. Now, I could give you pretty much the same question, but instead of saying find in radians the angle of the sector, what if I had just said find, oh no, that's not right. I was going to say find the area. You've probably still got, no, yeah, it's a good one. So find the area of that sector. But in order to find the area, you need the angle. So it's not saying, please do this, then do. So that's the same skills, it's just taking it one more step. Does that make sense? And I bet you that's probably going to come in a question shortly. So before you could find the area, you would have to find theta, and then you can go on. But this question, I just changed. You don't have to find the area. It was just asking you to find the theta. Nancy, you got to pick up a pen. We might not know. The sector has an angle of. So I would, if I wasn't sure, I would at least draw a little diagram. So I've got my sector. This is 107.9. The first thing I notice is this is in degrees. And I was telling you before, like change your calculator. It doesn't matter. It's only when you press the sine, cosine, or tangent, but that comes a bit later on. So it's like, if it's in degrees, use degrees. If it's in radians. But for this stuff, when there's no sine, cos, or tan, you're okay. All right, and we've got an arc length of 5.92. Find its radius. So we want the radius. And straight away, I'd like you to be thinking, yeah, that's L, the arc length, is radius times theta. However, when you're using this formula, theta has to be in radians. It's got to be in radians. If you don't want to change it to radians, or actually, we're going to go both ways with this one. So we're going to go length equals radius times, how do I change degrees into radians? times by pi over 180. Agreed? You were doing that for homework. So that would change it into radians. Therefore, oops, how do I now get r by itself? Radius is being times by all of this. How do I get rid of the times? Divide, right? Don't separate everything, whatever. Just go, yep, I'm using the skills of my calculator. I'm going to say just divide by 107.9. Sounds like a radio station. And get your info. Correct? If you didn't want to change to radians, we're back into a year 8 question. It's a fraction of the circumference. Now remember, circumference is 2 pi r of a whole circle. You've got a fraction of a circle. So you could just go, this is 2 times pi times the radius, but it is 107.9 out of 360 degrees. And again, we have our arc length here, which is 5.92. Right? How do you get rid of all that times? Divide. And if you have a look at it, you're going, yeah, that's going to be exactly the same, because what's the 2 and the 360? What does that cancel down to be? 2 into 360 is 180. Isn't that exactly the same? These are the same formulas. I swear to you, if I went and got a year 8 textbook, similar question. They're just confusing the pants off you. Is that okay? Now, some of you would have seen this thing called the unit circle. I hope you would have seen. If you don't, in a minute, once I show it, you'll go, Kills me through the years that a lot of students write out the unit circle. I'm going to get you to do it and fill it out and stick it in your book, but then I really don't ever want you to write it out fully ever again. Teachers in the past have given them students photocopies for their tests and whatever. No. You need to understand how it comes to be, but I don't think you ever have to actually have a whole unit circle there to do it. Anyway, I digress. I'm going to work in degrees just so you get the gist, but as you develop, and I'll give you a little sheet to fill in later on, you will transfer it to radians, okay? So we should get to the point where I will see 30 degrees and in my head I go, yeah, that's pi on 6. I will see 180 degrees and I also go, yeah, that's 180 degrees, right? Anyway, here we go. We have a circle. It has a radius of 1. We're going to start at 0 degrees. I'm still saying, I'm going to start at 0 degrees, and then as we go anti-clockwise, clearly this one will be 90. Ags, we're listening. And by listening, that means you're looking and listening. Didn't look like you were. You're looking at your screen. So over here, we've now got 180 down here, and then back up to 360. Your sine and your cosine graphs are basically graphing the vertical height and the horizontal height of a particle moving around this circle. So we're going to look at the sine one first. Shall we go sine for blue? Sure. So over here we are starting at this point, and so what is my vertical height? How high have I gone at this point? 0. So are we happy that that is also 0, 0? But as I travel around, my particle is now going up here. The height is increasing. Shut your laptop. That's the second time. Your height is increasing, and so then when we get to 90 degrees, how high have I got? So at 90 degrees I keep traveling around. And then at 180 degrees, my height is 0. Keep going. my height is now? -1. And you can see where this is going. Now, if I was to actually graph some of these, and we'll show you in a minute, let's take 30 degrees, roughly 30 degrees. I can make my little triangle there. This is what length? 1. And if I wanted to find this height, so let's call that y. Opposite over, I'm trying to prove, I know what it is. We're trying to prove it. So we've got sine, would you agree? Opposite over hypotenuse. So sine 30 equals y over 1. How do I get rid of the divide by 1? So y equals sine 30. Now I am in degrees, so if you pop that into your calculator, sine of 30 degrees we get 1/2. And you can see, even from my dodgy not to scale diagram, that pretty much looks like a half, doesn't it? So over here, third is 30 degrees and we get a half. So as the particle moves around, it's increasing and then it starts to decrease and it's a nice smooth line, and that is how we get our sine graph. Now it can go loop, 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 so it can be continuous. It can keep on going and it can keep on going this side. Do you remember this? Some are my people saying are good, nodding. Your cosine graph, shall we go pink? Your cosine graph, instead of doing the vertical height, it measures the horizontal height. So here, what's my horizontal height? So it starts up at 1. As you are traveling around the circle, what's happening to this horizontal height? It's decreasing until it gets to 90, where the horizontal height is 0. Travels around again, and the horizontal is now -1. It travels around, it's 0, and then it's up to 1. So you get this, and that is your cosine graph. And they keep going and going and going. So this is your sine graph. It's moving around the circle and it's graphing it. Oui? My year 10s, if you can remember, what we want to try and do is hit cosine as it hits the 0 mark again. Who would like to do that? Who's on the, you're too far away. Okay, you tell me when to press it. No, missed it. Ready? Whoop! No! Too early. It's sensitive. It was a sensitive presser. I missed it. But you can see this is going around the circle several several times. Nice. It's very soothing. Someone always asks about tan. We will discuss that later as to why this happens. I'm pausing on the video now. Nearly there. Here, what if I now wanted to find this bit here? So my cosine one. So we're going to call that x because it's going along the x-axis. Ags, once again, I'm going to have you sitting up the front. That's like 3 times. You're not listening. So once again, I'm looking at that triangle, right? This triangle here, that's 30, that's 1, and this is x. So how do I find x? Adjacent over hypotenuse, which is cos theta. So cos 30 equals x over 1. So therefore x is cos theta. Can you pop that into your calculator? No, it is not 1/2. It cannot be 1/2 because look, this is nearly at 1. So root 3 on 2 is like 0.86 something or other. Makes sense that it's pretty much, yeah? So this coordinate This is important, people. The x-axis, the horizontal, that was graphing your cosine. You don't have to get any of this. I'm going to give it to you. This is graphing your cosine, right? Your vertical was graphing your sine. So does it come as any shock that the y-axis is actually called the sine and the vertical is called the cosine? And so this now coordinate that we've got, so this coordinate, right, and any coordinate around here we know is x, y, but what is our x? Cosine. And what is our y? Sine. So this coordinate here, we've gone across, that's the cosine, so that's root 3 on 2, and we've gone up to a half. So when you're reading your unit circle, what we can say, or we know, is cos of 30 degrees is root 3 on 2, and sine of 30 degrees is a half. Big whoop doop. Well, it's great, because now if I use symmetry, I've come up 30 degrees here. What's 180 take 30? 150. I already know this coordinate, do I not? It's come across the same length, but it's now negative. So root 3 on 2. And how high has it gone? Half. So I now know cos of 150 is negative root 3 on 2. Check it out. Is it? Or am I just lying to you? And sine of 150 is half. That corresponds, here's 150, here's a half, right? 30, 150. Where this is going is that in year 9 and in year 10 at the start, when I said sine of theta is a half, you went, yeah. To get rid of the sine, you did sine to the minus 1 of a half, and it gave you 30 degrees, right? That's what your calculator gives you. That is not the only answer. There is now another answer. Yeah? If this graph keeps on going, there would be another answer and another answer. There's infinity number of answers. Depends on your domain. Wait. You can keep going with this, and you can now go, well, 180 plus 30 is 210, and what would its coordinate be? Still minus root 3 on 2, negative a half. You can do this one as well, correct? Yeah. That's what I'm going to ask you to do for